Good evening. You're very welcome here to this talk about computer intelligence. I'd like to start this talk with a short section that I'm going to read out. I'm not a peace officer, Rick said. I'm a bounty hunter. From his open briefcase, he fished out the Voigt camp apparatus, seated himself at the nearby rosewood coffee table, and began to assemble the rather simple polygraphic instruments. This, he held up the flat adhesive disc with the trailing wires, measures capillary dilatation in the facial area. We know this to be the primary automatic response. This records fluctuations of tension within the eye muscles. So this is a short reading from a book called Do Androids Dream of Electric Sheep by Phil Dick. I'm sure some of you know it. It is relevant for this talk, and we can come back to this. Again, you're very welcome to this talk here in the Science Gallery related to the live blogging event happening outside. My name is Kevin Koidl. I'm a research fellow in Trinity College, and also work with the newly funded ADAPT Research Centre, which relates to content intelligence. I have a small startup from Trinity College called Ripple.com in the personalization space, and cafehouse.com, which works in poetry translation. I'm here with Parsa Ghaffari. He's the founder of AYLIEN, an AI company which focuses on natural language extraction and natural language programming. And as I said, the topic today is about computer intelligence, and we would like to keep this a little bit, I should say, conversational in some way, like to bring you in as much as possible. Could I get a show of hands? Who is a computer scientist or some kind of expert in that field? Okay, would you please leave the room? That's okay. Could we maybe get 3 questions from anyone in the room? Just 3 questions. Obviously, it's really nice of you to come here today and listen to this topic. And just 3 questions of what brings you here. Is there a question related to computer intelligence that brought you here, or something that you would like to hear something about?
Oh, sorry, man. Hi. Yeah, I was just wondering if we actually understand enough about human intelligence to be able to define computer intelligence.
Okay. Do we understand enough about human intelligence to understand computer intelligence? Very good question. Maybe a second one up there.
How you doing? It's just really to try and understand how close we are to achieving what we're putting out here today.
How close we are to achieving, I guess, computer intelligence. Yeah. Yes. Maybe another one. Yeah.
Thank you. How will we work with improved artificial intelligence or super intelligence? How will we change our values and our organizations?
So those are really good questions. I kind of have them in my mind as well, so very, very nice. What we're going to do here today is I'm going to start just briefly explaining, and there's a couple of computer scientists in the room, and some of you maybe know about this. I'm just going to talk about what a computer is, what intelligence is, or what we think it is, and then what computer intelligence is, what a lot of people also call artificial intelligence. I try to keep that brief. I'm not going to go too deep into any of those topics. It's a big hype at the moment, so maybe that's a good thing to kind of know more about. Parsa is then going to move into applied AI, or some examples of how you can use, or what you kind of see out there where AI is used, or computer intelligence is used. And then we're going to talk briefly about implications of computer intelligence. So what are these implications? There's just like that last question, there's ethical issues, there's privacy issues, and that hopefully triggers a little bit of a Q&A after this presentation, where it'd be nice just to hear, with the understanding of the talk, how this could work or how this should work. So I'll briefly go into a bit of history of computer science. I try not to bore you too much because I'm kind of excited about it, so I'll try not to wander off. So what is a computer? So a computer is actually a very basic concept. It's the idea that you have a central processing unit, a CPU, and this central processing unit can conduct or execute logical or arithmetic operations. And in computers, that's a sequence of zeros and ones. And they get processed by setting transistors, and there's CPUs now with up to 20 billion of those transistors in a small space, setting sequences of zeros and ones, and all what that does is calculate, hence the word computer. Now, obviously, there's some kind of input, there's some kind of memory, there's some kind of output, but that's the basics of a computer. And there's different versions of computer. There's a nice computer that came up, one of the first computers in 1946. Anybody know what the name of that thing is on the left corner there? Anybody have an idea? Eniac, yes. Who's that? Oh, okay, he knows. Eniac. It's an electric numerical integrator and computer. 27 tons in weight. It was used to calculate ballistic missile or ballistic trajectories. It was also used to simulate a hydrogen bomb. So pure calculations. Now these big computers, the basic concept of a big computer is still there. It's just a lot smaller. And that's what some people call a Raspberry Pi or other devices where you can just use a very small space, same concept, you get your computer. Anybody know what that third image is? No? Yes, that's a quantum computer. So that's a new wave of computers where we suddenly have not just the operations of sequences of zeros and ones, we suddenly have a whole set of zeros and ones seen as one state. So suddenly the complexity has grown exponential and can be processed. But these are all prototype things. It looks a bit like a laser or some kind of operation instrument. But this is just a brief idea of computers. The interesting thing is that every computer, so if we talk about computers, goes back to a concept called the Turing machine. It doesn't really go back to the concept of a Turing machine, but you can simulate every computer on this planet, no matter if it's in the past or most likely in the future, with this simple Turing machine. So it's an abstract device that can manipulate symbols based on a set of rules. And that's the next really important part to understand, the set of rules. Now, this set of rules is also known as algorithm. So this guy here to your left, he's old Persian, let's say. He's from I've noted it here, he lived 780 to 850. His name is, now this will be interesting, Mohammed ibn Musa al-Khwarizmi. So he came up with this idea that you can use an algorithm, which is a set of rules, logical rules, that operate, basically it functions, and it repeats, so it's repeatable. And there's one very important thing that we have to understand, and it's very important for computer intelligence and for our debate, is an algorithm terminates. So if you look at that flow chart in the middle, there's an end. When you go down, there's an end. So if we talk of artificial intelligence, I'm kind of jumping ahead a bit, something has to so I don't know if I'll die someday, but do the algorithms in my head or the process in my head, do they end? Do they have some kind of purpose? I'm aware of that purpose. So that's a really important concept, understanding the limitations of computers. On the left-hand side, you also see a code snippet from a language called Lisp. And Lisp is the language that was traditionally used to teach and also to express artificial intelligence applications. But I'll just kind of briefly tell you what we understand under intelligence. So I guess, would you say this behavior of Homer, would that be intelligent? Just to get an idea of intelligence. So he's looking for the Ani key and just doesn't get that, obviously. So what do we understand as intelligence? Very simple definition, Webster Dictionary, the ability to learn or understand things or to deal with new or difficult situations. So the ability to learn and then to deal with new or difficult situations. The second definition is kind of nice on the wake of privacy concerns and Snowden affairs, so it's kind of was a surprise to me to see it there as well. But now we're getting closer to the idea. So we have computers. We know what computers are, just the basics, and I'm sure most of you knew that before. Just wanted to kind of put it back into context. And we have intelligence. And now if we bring this together, the basic concepts of a computer and an algorithmic approach in that, a logical arithmetic approach, and then we take intelligence, what we think intelligence is, and we bring that together, we have computer intelligence. And that now, the word that is used a lot is artificial intelligence. It's a little bit of debate about that word, because can we actually have an artificial, people like to use machine intelligence or computer intelligence more than artificial intelligence. Now, so would you say this is a computer intelligence? And maybe some of you saw the movie, so like an android. So this is kind of a movie where this super researcher creates an android and wants to test if the android is human similar. Now, the traditional model to do that is called a Turing Test. I'm sure some of you know about this. So if a machine can deceive you in making you think that it's a human because it behaves like a human, then it is artificial intelligence. So it passes the test, and this movie is about it. There's other tests as well, funny ones. There's the coffee test. So if a machine can make a coffee, press the right buttons, put in the coffee into the right things and everything, and make a nice cup of coffee, then it's artificial intelligence as well. Or if it can find a job, be employable. There's a list of different tests that go back to academic papers, which some of them are really interesting. Who knows who the guy is on the left? Any idea who's running away, pissed off? No, yes, Gary Kasparov. And what happened with him? Any idea? Yeah, he lost, and he's still not really sure about if he lost. He still thinks there's maybe someone who was humanly altering the algorithm. So it's kind of he's not so sure yet if it was actually a machine that got him. There was one move where he thinks a machine couldn't be doing that. Now, the thing that drove that was a machine called Big Blue. So there again, we would have an intelligent computer in that narrow definition. The second one is Jeopardy, another game that IBM trying to beat, and they successfully did it, which is the Watson approach, or the Watson computer. Now, just very brief slides, very, very brief, and then I'll pass over to Parsa. What we define as computer intelligence or artificial intelligence. So artificial intelligence is actually a very academic field, and it goes back to what we call agents or intelligent agents. And intelligent agents are autonomous entities that have sensors and then act on or have a certain agent or ability to change something in their environment. And there's different level of agents. There's like rational agents, there's learning agents, and there's a whole academia around it. The important part, though, is that an agent is directed towards a certain goal. So it has this algorithmic rational notion inside. So it's very important to kind of take that home, that artificial intelligence at the moment, as we know it, is driven by a rational approach. So it's driven towards a certain goal, and rational means something like that I want to put very little in, I want to maximize the output. So that's a really important thought. And if we have intelligent agents that are based on computers and based on what we think is intelligence, we have this rational notion. And why I'm saying that is because there's something part of the debate that we'll have after this. What is motivating this hype in AI? Why are we so keen on getting this out and done? Now, there's two fields in the AI. One is called general AI and one is called narrow AI. Now, general AI is this notion or idea that we can create, almost say a replication, so it goes back to one of the questions you had at the beginning, almost a replication of what we think is intelligent. So can we somehow create a system that allows us to upload our brain? So a brain upload, a full simulation of what we think is intelligent and what we are. It goes back to the notion that currently we would also think that we are biological machines. So we are in some way machines. So if we are machines, if we believe we are machines, we can somehow replicate that through simulations and so forth. Now there's certain criteria, so again, Turing tests and different tests to test if something is intelligent, but the typical list is that a general AI should be able to judge in uncertainty. So that's something that is very hard if we think back to what an algorithm is or what a computer is. A set of rules. So how can you design a set of rules if you don't know what is actually happening? So general AI is judgment under uncertainty. Common sense knowledge. Common sense, cultural context, so it's a bit of a wider kind of more general, broad approach. To plan, to learn. And the last part is something that Parsa is going to talk about, is being able to communicate and with that understand natural language. So that's a real big, strong research area in general AI. Now, if we bring that back to our current world, or what we know as AI, we have general AI, which is motivated by let's live forever, let's upload our brain, let's replicate ourselves somehow. And then we have narrow AI, and that's what everybody at the moment is mostly talking about. General AI is a nice topic, it's researched, it's done a lot, but narrow AI is what everybody is after. And the reason here again is because it's driven by an intelligent agent, which is again based on a rational principle. So all these examples on this screen are driven by companies that are mostly interested in economic outputs. And that's something what AI, or narrow AI, is very good at the moment. Crunching information in certain set conditions. So we have a couple of examples here. Let's take the first one, is Siri. Siri is good if you kind of say, what time is it? Or if you say, what will the weather be like tomorrow? There's some gimmick questions as well. What's the reason for life? And it gives you some answer. But on the back of that, you have a database that knows what you're going to ask. And it has a lookup table, and it just kind of pulls it back to you. So if you ask something that is outside of those limits, like, how can you make me feel better? It'll maybe give you some phony result, but it doesn't really know you, so it's not going to say anything that makes deeper sense. Second funny little looking car. Any idea what that is? Google car? Yes. Perfect, that's the Google car. So cars are a really nice example of intelligent agents on narrow AI. They work very well in set settings. So if you're driving down a road which has certain behavior associated to it, this car can actually do very smart decisions. But again, the decisions are based on a certain algorithm, which somehow has to be created. Third one, search result. I'm putting this on because it's kind of important. Again, it relates to some of the things that is happening in the natural language processing scene. Search engines are turning into question and answer machines. So it's not just about putting a few keywords into that little box and then getting some kind of document that matches against those keywords. It's actually trying to understand, and that's again the understand part, it's trying to understand what is that person actually asking, or what is the purpose of that question. And how can we understand what the purpose of the question is to give some kind of senseful or good answer. That also has huge implications on machine translation, trying to understand how to translate context, how to translate language, and so forth. And the last one is basically image recognition, or how to get or understand what an image is about. So these are the hot areas in AI at the moment. Like, that's something that I could, and Parsa could talk about for hours. So there's these two worlds. There's the general AI and there's the narrow AI. And I'll pass over to Parsa now, and then after that we'll talk a little bit about the implications of AI and bring you in a little bit.
Great. So thanks for the great introduction, Kevin, and great to see you all here today. It's great to see so many of you interested in AI and these technologies. Just for me to maybe know a little bit more about you guys, how many of you were familiar with AI before coming here today? Can you show hands? Okay, great. So where do we start from? Okay, so can I have the clicker? So basically, the notion of AI as an algorithmic way of mimicking intelligence has been around since the 17th century or so. But it was only recently, maybe in the 60s or 70s, that we realized, or AI got to a point where it could do things actually. And since then, AI started sort of branching into, let's say, general AI, which is driven by scientists and tries to solve more than one task. Its aim is to really understand what's happening. And the other branch, which is narrow AI, which is driven by the industry, driven by economics, driven by results, to solve problems basically that we have, let's say, in the industry. And it's usually geared towards one specific task. And so the goal there is to create practical applications. So as you can see, there's a big difference between these two. And to make it clearer, let's say if our goal was to predict what's going to happen in this room in the, let's say, next few moments, one approach would be to actually maybe ask the physics department, and they would do all the analytical calculations and perhaps come up with a prediction of what's going to happen next. But another approach would be to actually collect all the data that we can from this room. So let's say all the video that is being recorded, all the audio, and feed it to a supercomputer and run some statistical modeling on it, some Bayesian model or something, and we would get a far more accurate result than the one we would get from the physics department. But so what's the point of having a physics department then? So basically their aim is to, let's say, a physicist's aim is to understand why things work the way they do. But in, let's say, narrow AI, we really want to be able to predict things. And that's the main differentiator between these two branches of AI. So the examples that Kevin was giving about, let's say, Siri and self-driving cars. So let's say the AI we have behind Siri is not capable of driving a car. The AI we have for the self-driving car is not capable of giving you answers or playing chess. And that's what we mean by narrow AI. Basically, it's narrowed down to a specific problem. But I mean, at the same time, I think it's important to keep in mind that these problems are hard problems for a computer to solve, and it took us decades of research and billions of dollars to get to where we are with Siri and self-driving cars and things like that. And some of the things come very naturally and easily to us as human beings, such as understanding language. Understanding lingual and visual information is one of the things that again come very naturally to us. So for instance, here we have a tweet. And within a fraction of a second, you realize that it's written in English and it's written by a person who's complaining about something. But doing the same thing would be challenging for a computer. There's a lot of ambiguity around language, and that makes it very difficult for a computer to fully understand what's being said, even in a tweet. Actually, it gets harder as the text gets shorter. Because you lose context. So just to give you an example, so in the sentence, I made her duck. So I made her duck. How many meanings or how many different interpretations are there for this sentence? Two? Well, there are actually four. So the first one is I made her duck. I forced her to duck. Second one is I cooked her a duck. Third one is I made her a physical duck, like maybe out of wood. And the fourth one is I cooked her duck. Basically, I made her duck. So there are four different meanings that could be basically expressed in the same way. And again, as a human, we are able to pick up clues that allow us to quickly find out which one is meant here. And the same is could be said about vision. So when you look at a photo or a video or any type of visual information, you can, within a fraction of a second again, realize or recognize what objects appear in that photo, their state. So here we have a picture of a man with his dog on the street, and we're able to actually very quickly pick up these things from the photo. But again, it's a very hard thing to do for a computer, or hard thing to say the least. So again, I'm sort of coming from the industry, and I sort of cringed when I saw artificial intelligence expert there next to my name. But so I basically, what my background is revolves around applying AI techniques to various problems in the industry. And so that's what I do at my company, AYLIEN, as well. So what we do there is we create technologies for analyzing and understanding text and images, so the things that we were going through. And so we make these technologies available to software developers that, so they can tap into these technologies, and wherever they have a piece of text, let's say they're looking for some information on social media, analyzing tweets, analyzing web pages, blog posts, and so on, they can basically utilize our technologies to make their job easier, so we save them from having to deal with the gory details of machine learning and NLP and so on. So combine this with the second problem, again on the business side of things, which is the amount of content on the internet is growing exponentially, and as Condé Nast reported, more content was uploaded yesterday than any one human can consume in their entire life, and so you have this. Let's say lifetime worth of content, and you have millions of conversations surrounding it. And as a business, in order to make, again, smart and good business decisions, you need to understand this information, which is a form of narrow AI again that we're trying to solve at AYLIEN. So we again provide these technologies for analyzing all sorts of documents and extracting different types of information. So we have things like classification. You have a piece of text, you want to find out if it's about sports or about technology. If it's about technology, is it about computers? Is it about oil technology? Is it about some other kind of technology? And then entity extraction, so finding mentions of entities. There are certain challenges here. So if you spot Apple, let's say in a text, is it referring to the company or the fruit? And then image tagging as well, so identifying objects in images. And as you can, as you might guess, there are a wide variety of use cases for these type technologies across different verticals. But we're going to focus on one of them today, which is basically building taste graphs. Or maybe I can give you examples of the other ones as well. So social listening. Let's say you're a company and you want to know what people think about your latest product or your brand in general on social media. So one way to do that would be to collect tweets and let's say Facebook posts and so on and so forth, mentioning your brand and analyzing their sentiment. So sentiment analysis is one of the major tasks in natural language processing, which is a branch of AI where you want to determine if an expression is positive, neutral, or negative in the simplest form. So let's say you want to, again, find out what people are thinking about your brand or your product on social media. You would grab, let's say, millions of tweets, run them through a sentiment analysis system, and it will tell you if people are thinking positively, negatively about your brand. You could do the same about, with, let's say, your competitors. Then we have taste graphs. So this I'll get to later on. Then we have event detection. So nowadays, as soon as something happens, people go on social media and write about it. So there's this whole area called event detection where we try to detect events based on what people post on social media and perhaps before the news breaks. Then in news and media we have news monitoring, news analysis, news generation. Actually, a good fraction of the news articles that you read today are written by AI algorithms and not by human. And in advertisement we have so you don't want, basically the basic idea of targeting in ad tech is that you don't want to show your ads on an irrelevant page, so you want to have context of the web pages that your ads are going to pop on. So talking about taste graphs. So a taste graph is a digital model of a user's or a person's taste, and it can be so one of the ways of extracting it is to let's say grab someone's tweets and from Twitter, their photos from Instagram, their status updates from Facebook, and again analyze all of these to get a holistic model or a view of what a user is interested in. And so it has many business applications in marketing and personalization, which is something that Kevin has worked on extensively. So in the context of this talk and the most recent exhibition at the gallery, which is about lifelogging, how many of you are familiar with lifelogging? Okay, so it could be, so briefly put, lifelogging is an exercise of keeping track of your daily activities and let's say state of mind and things like that, and using that data to improve your productivity, emotional state, and well-being in general, and so on and so forth. And this exhibition at the gallery was about lifelogging, and there's so given this definition, how many of you do lifelogging on a daily basis? Okay, only 4. And how many of you use either social media or a search engine or a smartphone? Any of these 3? Okay, yeah. So pretty much most of us use one of those technologies. So the thing that we were trying to add to this exhibition was that by using social media, smartphones, search engines, and so on, you are engaging in a form of lifelogging without necessarily being aware of it. Every single search query, every single status update, every single photo you post on Facebook and Instagram, if we can trace it back through analytics and AI to your state of mind, people you were with, your context, basically, we can actually see that as a form of lifelogging, and which is something we proposed to the gallery as a project called Bigfoot, which we did just in collaboration with Kevin for this exhibition. So what we did Bigfoot was to basically combine taste graphs with lifelogging. So there's an element of social sign-in. So you would basically, we had an app that is actually installed downstairs. And you can connect your social media profiles, your Facebook profile, Twitter profile, Instagram profile, and it would go out and grab your publicly, or let's say even privately available, because you've authorized the app, data from these platforms, and would use our technologies to show you your taste graph. And again, this could be seen as a form of lifelogging. So here, for instance, we have the number of things you've liked on Facebook over time. So you can see, patterns that, in some years you've been, let's say, less active, in some years more. Or you could actually categorize your interests based on the pages you've liked, the status updates you've posted, and so on and so forth. So this one's from Instagram, and it shows a correlation between number of likes you get on your photos and number of comments. And you can see a very clear correlation between the two sets. This one's a more trivial example, but these are let's say, the filters that a user has used on Instagram for their photos. So you can, for those of you who are not familiar with Instagram, you can use filters to enhance your photos, make them more vivid, or black and white, and so on and so forth. And it could be an indicator of your, a part of your personality, maybe. And at least a part of your digital taste graph, we can say. And then we can do we can use image analysis and image recognition to find out what objects appear most frequently in your photos. So you can see a breakdown of those objects based on, let's say, your most recent Instagram photos. Or we can actually analyze your tweets and determine their polarity, so how positive or negative they are, and tell you, let's say, how positive as a person you are according to your social media profile. So this whole combination of AI and lifelogging could be very powerful as a personal tool for self-improvement. But it can get very dangerous if it's done at scale. Not necessarily dangerous, but a little bit scary, I'd say. So most people, when you tell them that maybe you're leaking too much information on your social profiles, will tell you that, I have nothing to hide. I only have a couple of photos with friends and so on. But actually, if 10 million people think the same way, you might be able to predict who's going to win the elections. So there's, that opens a door to a more general topic, which is about privacy and AI. So there are many challenges in AI, some of which were discussed earlier. But Kevin's going to actually now take you through the rest of the challenges of AI. So I'm going to pass to Kevin now.
Thank you very much.
Thanks.
Thanks, Parsa. So if you take this into context, the using social media and then using narrow AI to analyze what you're doing online, it creates some form of understanding. Just asking you basically to also kick off a little bit of Q&A. Would you think that what you've just seen, if I go back, if you would see this from let's say, this from a stranger, let me just find this. Would you say you would understand that person more? Who says yes? Okay. If it's a total stranger and you see this, or maybe you just had maybe brief conversations, not talk. But would you understand this person more? Who would say no? I wouldn't understand this person more. Okay. So we're just trying to motivate that this is something that moves into the field of understanding. So if we use social media, which is very powerful, and it's a little bit beyond information almost, it's context about your personality, machines can try to understand what you are about. But if they really understand, that's a different question, and maybe we can debate that. But it brings us closer to what AI can become. Because if a machine fully understands or gets all that information, a machine could maybe start saying, okay, let's play golf, because that's one of your things, and I understand that that's the thing you really like doing. Now, the implications that has, let's talk about this one. So this is someone who's very freaked about his privacy, so he doesn't want anybody to see what he has on his screen or what he's doing. And now again, just a question to the floor. Who's worried about their privacy online, their digital privacy? Yeah, who's not, which is a much more interesting part of people here. You're not, okay, I'll keep that in mind. and now the question is, why would you be worried? Like, what can happen? Like, a lot of people I would talk to would say, I have nothing to hide. What can happen? Like, we have we'll talk about 3 areas where AI are positive because they can do great things. They help you understand more about yourself and help you optimize and become more intelligent, but they can also create some challenges. The first one would be privacy. Why is this a problem? What do you think? Just get some comments off the floor, maybe. So I just repeat that that everybody hears. So images can be taken out of context. Why would that be dangerous? What could happen? So an employer would do what?
Only posting pictures of him drinking.
So you would just to relay that back, you would say, I am worried about my privacy because an employer would see images out of context where I'm maybe out there with buddies having a few drinks. But what would that mean for the employer? Why would that worry you? What would that employer maybe do?
They might prefer somebody who appears to drink less.
Okay, that's fair. Okay, let's get another.
Okay, I've just moved back to Dublin from Singapore, which is a very wired society, but with a very repressive government and completely controlled media space. If I'm voicing any opinions on social media, or the government think I will, they can put pressure. They can find out, who I'm sleeping with, who I'm doing business with, who I'm meeting, or possibly agitating or organising with. All of those kind of things. The potential just for quiet blackmail. When there were no legal restrictions on that government at all.
So what? Why are you like just to be a bit more conversation about this? Like, what could happen to you? Okay, then the government in who knows where, in this case Singapore.
Well,
what happens?
For me as a foreigner, I'd likely be briefly imprisoned and expelled. For a local, you would lose your job with certainly any state institution or any private sector employer. They would retaliate against people, your family and your network as well. So
your concern would be limitation, like you would get into a prison, limitation of freedom, limitation of employment or choice of employment, which is similar to the other gentleman.
Not even that, just the ability to be employed.
Yes. Okay.
Because sorry.
Okay. Can just there was two more maybe.
Hi. Data analytics and advanced kind of information gathering has already been weaponized by the criminal community online, and is actively exploiting to the tune of almost $700 billion per year. That's how it affects you.
Yeah. So, do you know a little bit about that exploitation? What is happening there?
The extraction and the pattern recognition within either stolen or legitimately received
what happens
data.
with that information?
It's
what can they do?
used for financial, political gain. It depends on the criminal organization.
So hacking or getting into bank accounts, stuff like that?
Monetary, but also influencing through kind of social aspects. My English is
no, that's fine. That's fine.
The holding someone to blackmail. Just for the fun of it.
Criminalization of your information, basically, using
you
as a weapon or your information. There was one, maybe, did you have another one down here? Yeah, maybe. Could we just have one here?
So the idea of catfish and all your personal information being used by maybe an AI to summarize yourself online and replicate yourself and to communicate to other people, or to tap into the previous one as well when your information is stolen and then used against you as well.
Yes. So that relates a little bit to the criminalization, where you get this idea that if things basically, if machines start to understand a lot about how you write, so Parsa mentioned in one of the sentences, one of the things that is happening at the moment, press articles are written by computers. So there's a lot of press announcements at the moment that are going out directly computer written, 100%, short ones. Now, what we're starting to do, and a lot of research around that, is to create, it's called natural language generation. So to start understanding the syntax, the way people are talking, the way they're writing, and so forth. So to create some kind of voice, to automatically recreate the voice of that person. So that is one of the great applications, because they're very, very, very good for commercial scenarios, but also one of the dangers that you actually have somebody simulating you in front of other people in social scenarios to extract more information, to exploit, to get some money, to understand if you're on holidays and maybe break into your house and so forth. So we have in this category of problems, and again, just to keep this kind of open, we have in privacy, why should I care? And AI is very big in that area and is continuing to get smarter as well. Why should I care? A limitation of freedom. So I could be put away by someone because my information is misunderstood. The second one is limitation of employment, limitation of movement, of taking part in societies. And then, of course, the third one is being somehow exploited or used or simulated. There's another one that hasn't come up here yet, and it relates a little bit to the limitation of freedom, and it's happening a lot at the moment. A lot of companies are starting to do AI or now AI-based profiling. So if you have a certain purchasing behavior, and then you go up to a mobile provider, then that mobile provider can figure out what kind of commercial score you have. What kind of behavior do you have? What kind of information? What are you doing with social media and so forth? And that can then trigger deny to that service, because that company then knows, based on the information, that you're not a good customer. So that's something to be a little bit aware of, where based on the information and the understanding of that information, you can create limitations. Now, obviously, this is all deliberately, we're doing this deliberately just also to trigger your thinking in the AI area. So there's two sides of the coin. There's good things happening in AI and there's not so good things, and this debate is important to understand what can happen. So that's the privacy part. The second one is known as moral dilemma. Now, this is a lot more in the general AI sense and relates a little bit to questions that were on the floor at the beginning, and I'll repeat them in a minute. If we take a self-driving car, and just use this example. A self-driving car is driving up to a bridge, and there's a person in the self-driving car but not driving, and then somebody jumps in front of the car. Last moment, jumps in front of the car. Now, the AI or the algorithm has to make a decision. I hit that person and damage the person, or I drive the car off the bridge and damage who's in the car. Now, what would you do as a human? in this moral dilemma?
Stop the car.
You can't stop the car. It's too late. You're like, that guy just jumped like last minute. Okay, so we have already two conflicting. Hit the person, preserve yourself. Who would drive off the bridge? Okay, a few people would drive off the bridge. What were you? Well, okay, I can, and that was my fault. let's say he fell, he stumbled or something. Let's say because that's a bit like. Let's just imagine that's not, and it's in a split of a second. So you're reacting in a split of a second.
I don't think you think about it instinctively. You try and avoid something. By instinct, you wouldn't mean to go over the bridge, but instinctively you would do that.
So,
Instinct
instinct would be avoid. Okay, so. How do you think AI could solve that dilemma? Or how would AI, if you're designing an AI, let's say you've all listened to the boring stuff I talked about at the beginning, and you listen to the exciting stuff Parsa said, and you put that all together, and your background in this field, how would you design let's say you're an engineer of companies that are doing this at the moment, how would you design this? How would you avoid this? What are you going to do? Probability of lowest damage. I like that answer. Okay, how do you do that? How do you who defines what damage? Like, maybe who said that? That's the next one. That's the societal. That's the next slide. Just keep that in mind there. But let's just briefly, and we only have a few minutes left. Just quickly, probability of damage or probability of who said that? Just could you allude on that a bit?
So actually, I know this.
Oh, great. Let's talk about it.
For me, it seems like the only thing that distinguishes the AI from the human, because as we said, we're either acting on instinct, or if
yes.
you got, let's say, SUV and some other car, then probably you wanna hit something, the bridge with SUV than smaller cars. So
yes, but how would you calculate the probability of as you said, lowest damage? How would that happen? Like if you're writing this algorithm,
so it's algorithmic, I would say, in a way. It's if your car is safer, bigger, then you can count that on base of let's say 10,000 other accidents that happened. So historical data, whatever.
Okay, well let's just follow that thought just for a second. So we have an algorithm that decides a probability or calculates a probability of. In that choice, calculates probability, where's the damage higher? Now, let's say this AI knows a lot about the two people. Does a quick scan within a millisecond, because we have the technology, knows the person who fell on the bridge is a father of 3 kids, very important, very high up in the government, and the guy who's in the car is actually a no good. So yeah, just throwing it out there. Now, so suddenly you create, okay, you have a probability of. You can calculate, okay, this person is like 20 years old, the guy in the car is 50. If I hit that guy, he'll have less damage than the guy driving off. Okay, that's a little bit objective. Yes?
Would the computer be able to tell the well-to-do man who has children and has a good job is suicidal, and then decide if the man is in the right position to kill himself?
Could you just repeat that there?
So, if the man is in a good position to decide if he's able to take his own life by jumping in front of the car now as well.
I don't know, maybe. Yeah, I mean that's. But then what I'm trying to trigger now again in understanding AI, obviously I'm framing this a little bit, so I hope you don't mind, is who will decide what that lookup table looks like? So who will, if you calculate a probability of values, so even in non-deterministic scenarios or some kind of values, somebody will have to still set some kind of variables or some kind of constants where you kind of say, okay, this score now means hit the guy, this score means drive off. So, yes? No? Maybe not.
You can stick to...
Wait, just wait a sec till everybody hears us on the mic. And we're almost done time-wise. I just quickly hop to
So I would just say that, we can stick to certain values which say human life is human life, and there's one guy, another guy. One might be bad guy or another is good guy, but then it's 1-to-1, and then it's just, the probability of who's gonna suffer less, and we don't make a judgment or whether this person is good.
Well, you see, it just brings me just to the last slide, which is the societal impact of AI. So are we ready for this? There's questions at the beginning, like do we can we actually talk about, do computers understand, because we don't really know how we understand ourselves? The last question was as well earlier on, like, as a society, are we ready for this? Does that kind of work? So there's a lot of talk at the moment about losing your jobs because of AI. Who's worried to lose their job in their lifetime through machines? Only 2. I'm worried a little bit. Wait. Yeah, well, if you're a pilot, if there's a pilot in the room, you maybe put your hand up. So just sorry, the question there? No, I just said yeah, I'm sorry, yeah. So there's a societal impact. So let's just talk about this, how the society could change. Sorry?
So basically, you have all the columns there that can fly on the so you're always going to have toilet input where there's going to be decisions that the computers cannot make.
Okay, that's a very important question. Brings us a little bit back to the one before, where if we replace pilots with AI, you're saying there's always going to be a human somehow still, maybe
there's going to always be
a backup system that's a human, basically.
Yeah.
Yeah, but what happens, okay, we're not going too deep into this, but there could be maybe quick decisions where it'll take too long till the human decides. Let's say a drone in a military scenario would have to decide quick, can't wait till that soldier in some center does the joystick thing. So there's just the scenarios there where we maybe as a society have to think about it. Now again, there's only 2 people worried about losing their job because of AI. That's good, yeah. Wow, you must have great jobs. Very good jobs, yeah. Now, who thinks if AI becomes very strong and replaces more of your jobs, who thinks that would be good? I think that's good, yeah. Who thinks that would be bad? Okay, can I have just 2 or 3 comments why that would be bad? Maybe, I don't know, maybe someone from the side? Is someone from the side? No? No? Why would that be bad if AI replaced your job? Maybe the young gentleman here? No, behind him.
People start resenting technology.
Sorry, say again?
People start resenting technology.
Why would they resent it?
Because it's stealing their jobs, it's ruining it's lowering what they're able to do with their life.
Well, why would it lower? I mean, if that machine takes my job, I can do loads of shit that I just like to do. I mean, why don't I?
If society, that's saying that society will change and go, oh, no one needs to work anymore because we've got robots to do it for us.
It's great. I'd love that.
Okay.
I'd just kind of read poetry all day.
Society probably wouldn't do that. I don't think people would be so quick to go, oh, we'll just let robots run everything and we can just all have a great time.
Yeah, so maybe the lady here.
Well, the first thing that comes to mind is you lose control. So someone makes a decision for you, and then if you have your own job, you can make the decisions based on what you think might be best in your job, but if someone else takes over, you're not making the decision anymore. And if you don't have any other job, there is no job to make decisions for, and they're made for you by someone else. In this case, it doesn't really matter if it's a computer, because it's about decisions generally. You can influence other people directly as well. But if no one human has a job anymore and it's all by computers,
yeah.
There must be a limited amount of people who still influence those computers. Well, but it's generally, it narrows down the amount of people who have the influence.
Yeah, there's a lot of theory about that question. Like we were talking with Parsa, we have like 2 different views on where AI will maybe go, and we kind of, before this, we made sure we don't start debating against each other. But there is figures like that 2%. A society at the moment, as it stands, would only need about 2%, like 2% human assisted. So 98%, which is almost everybody in this room, would not need to work anymore. But the real reason behind it, what we're trying to motivate is societal change, meaning are we ready as a society for a society that is not driven by, let's say, I need to have a paycheck, I need to quickly earn more money to do X, like I'm doing this job to actually do this. So there's questions in all 3 dilemmas: privacy, the question of, so basically if we go back, privacy, moral dilemma, and societal, that are way beyond the technology. Like the machines won't solve that problem for us, but they will catch up. If I say they, maybe it or he or she, I don't know, will catch up, and we will be faced. The self-driving car will happen in the next maybe 5 to 10 years, so there has to be some kind of ethical layer that decides how these probabilities are calculated. Let's use that example. And who would be sued if that car hits the wrong person? Is it the guy who programmed the AI? Is it the company that self-drove the car? And just to wrap this up, we're moving a little bit over. And just if you want to educate yourself a little bit more on this, there's loads of stuff on this, and we just put this up. So there's one book that came out, it's called Superintelligence, and somebody mentioned the word in their question earlier on, I mean, are we ready for superintelligence? This book is all about, are we ready for superintelligence? Now, this book is written from a very almost pessimistic view, and a guy called Elon Musk, who runs Tesla and is very much into self-driving cars and also trying to send us all to Mars and loves AI stuff. He read that book, and then he immediately put $10 million into that company or organization called Future of Life. I have nothing to do with them. I'm just mentioning it here. And they are trying to create an AI that supports us as a society. So it's an interesting thing if you're interested in this field just to kind of look into. And the third one is, with my academic hat on, use it a lot for teaching and things like that, is artificial intelligence, a modern approach, where you can read all about what an intelligent agent is, how they work, not so much about the societal things, also a bit, but it's a lot more computer science, how do I do this, how do I implement it, how do I understand it. Do we have, I don't know, do you want another question or two? Maybe 2, 3 questions, and then we wrap up.
How far or how soon will it be before we can see machines give us real good advice to help improve our lives?
Oh, who thinks that's now already? Yeah, so there's a couple of hands going up now, like now, not tomorrow.
I think it's...
You think now? Yeah. The person, do you think now?
I'm not aware yet of anything that's really valuable.
What would you, Parsa, what do you think is... to kind of...
My mic on? Hello? No. So was the question about AI giving good advice currently? Being able to give good advice?
At the moment, we need to go to people to get good advice and direction.
Yeah, so in a lot of analytical fields, like with stock trading and things like that, AI is actually able to give very good advice, which does not necessarily mean that it has to be true 100% of times, but it actually it could, like, it depends on how you define good advice. Is it accurate advice or is it useful advice?
I think
depends on how you define good and success.
I think emotional intelligence, artificial emotional intelligence.
I'm not really aware of any AI that's capable of doing that, but I think so in more analytical fields, it's as you would expect, it would start with those areas. So are we wrapping up?
No, just two more questions, and then we wrap up. 2 more. Maybe at the back, and then maybe someone who didn't talk yet.
So I'm actually interested in how does it compare to run a company, kind of startup or early stage company like AYLIEN, and developing AI versus Google, IBM, etc. So what are the capabilities, let's say, of a young company, or how does that compare, to the big?
Right. Yeah. Sure. So in general, as a small company, you're a lot more flexible, and you have the element of speed as well. So it really all boils down to these 2 elements. And as a rule of nature, I think any person or organization is successful exactly to the extent that it can do things that others can't do. So as a startup, you would really double down on again those abilities, speed and flexibility, to actually get ahead of those bigger guys that you mentioned, which is the case for us as well. So we have competitors like IBM Watson, but again, it takes us maybe a day or 2 to close the customer, whereas it would take them 3 weeks. Plus there are people always, a lot of people at least, always like to support new ideas and the smaller players, so you get the backing of investors and let's say talented people to.
In terms of really big problems, because I've been both through big companies and startups, so I kind of know about flexibility, etc. But do you think that you have to be much more narrow, or can you also tackle, like really big things like DeepMind, etc.? So is it possible for a small company to work on?
I mean, it surely
same
is,
scope
as
of
we've seen, like you mentioned, as we've seen with examples like DeepMind. So for everyone to know, DeepMind was a startup that was acquired by Google recently for about $400 million. And what they did was to create general AI for basically gaming AI. And so they created a system that was capable of beating humans, I think, in 45 different video games without any supervision or any learning. So you obviously have success stories of startups maybe specializing in something, but I wouldn't really call a game AI that's capable of winning or outperforming humans in 45 games a niche company or a narrow company. It was quite a big problem that they were tackling. So I definitely believe that is possible, but I'm unbiased, obviously.
Just one last question here.
Yeah, as AI works on data, so is it possible to manipulate an AI? As in, if you can create your own fingerprint online for a particular use, is it possible to actually manipulate a particular algorithm?
Should I? Yeah. So yes, currently it is quite easy to manipulate algorithms. Like there is this very recent example of people fooling image recognition, deep learning-based, RNN-based deep learning algorithms by inputting some form of gibberish, and then the algorithm thinks that it's a picture of a car or something. But yes, so in short, yes, the answer is yes.
So you can change the sentiment just by manipulating your fingerprint?
Yes, I mean, yeah. Currently you can do that. We might get to a stage where that's no longer an option.
So, okay, thank you for your patience. We're running a little bit over. So I hope, I mean, the setting here, again, computer intelligence, how do computers understand? I hope also the three questions at the beginning, they were not questions I could say yes or no to, or anyone I guess can very soon. But I hope it kind of triggers an understanding what computer intelligence actually means, what a computer is, what intelligence means. If you put that together, what that can become and what impact it has on society. So I very much hope you go home with the brain box kind of working on these topics and solving them in the next few hours. And if you want to go and see the Bigfoot app, we have that outside. If you want to click around on that and give us all your information so I can understand you more. And yeah, thank you very much for coming here this evening. Thanks.